In this lecture, we consider a space to be air conditioned located in the city of Hyderabad, which is at 17.86 degrees north latitude. The worst case summer outdoor conditions are 106 degrees Fahrenheit dry bulb and 78 degrees Fahrenheit wet bulb. The daily range is 14 degrees Fahrenheit. As far as the space to be air conditioned is concerned, the floor area is 8,000 square feet and the wall height is 12 feet, meaning the volume of the space is 96,000 cubic feet. There are 40 people working here. The computer load is 150 watts per person. Within the space there are 4 laser printers and 2 plotters. We will assume that you have collected enough information to identify all sources of heat load, and based on the last 4 lectures, you have estimated these loads, except of course for the heat load due to fresh air intake, that is ventilation air intake, whose quantum is yet to be decided. Now let us suppose you have completed the heat load calculations and you have estimated sensible heat load 315,833 BTUs per hour, latent heat load 9945 BTUs per hour, RSHF, the room sensible heat factor, which is the ratio of sensible heat load to total heat load, works out to 0.969. Clearly, sensible heat load is the major contributor. The AC system's schematic diagram is shown on this slide. As you can see, outside air, denoted OA, is introduced into the air handling unit return to become a part of the return air load of the cooling coil, unlike infiltration load, which is part of the room load. The cooling coil, besides cooling this mixed air, denoted MA, may also have to dehumidify it so that the room humidity specs are met. The question arises as to how much outside air or fresh air do we bring in. Table 1.53 of ISHRAE Databook 2017 furnishes estimates of fresh air required based on the usage of the space, the number of persons, and the square feet area. As you can see on this slide, the fresh air requirement works out to 680 cubic feet per minute. Apparatus dew point, abbreviated ADP, is the effective surface temperature of the cooling coil. Bypass factor, abbreviated BF, is that part of the total air flowing through the coil which fails to come into contact with the cooling coil. Typical bypass factors for various applications are shown in table 1.26 of ISHRAE Databook 2017. In our example, we will assume BF equal to 0.1. Clearly, 10% of the fresh air heat load is bypassed into the room, while 90% is not. The sensible and latent heat outside air loads bypassed into the room are shown in this slide. Pause this video and carefully go through the calculations. The sensible heat of outside air bypassed into the room works out to 2277 BTUs per hour. The effective room sensible heat is the total sensible heat directly flowing into the room. ERSH works out to 318110 BTUs per hour. Similarly, the effective room latent heat ERLH, that is latent heat directly flowing into the room, works out to 11517 BTUs per hour. The effective sensible heat factor is the ratio of effective room sensible heat to effective room total heat and works out to 0.965. We can similarly calculate the outside air heat gain not bypassed into the room. The sensible heat of outside air not bypassed into the room works out to 20490 BTUs per hour. The latent heat of outside air not bypassed into the room works out to 14149 BTUs per hour. So, the total outside air heat gain not bypassed into the room is 34639 BTUs per hour. On this slide, we have calculated the grand total heat load. It works out to 364,266 BTUs per hour or 30.355 tons. Tables 1.39 to 1.41 of ISHRAE Databook 2017 show the required ADPs for different room conditions and different effective sensible heat factors ESHF. For the cooling coil of our AC plant, ADP works out to 54.675 degrees Fahrenheit. In this slide, we have calculated the dehumidified CFM through the cooling coil using the formula RSH divided by room DBT minus ADP multiplied by 1 minus BF multiplied by 1.08. This works out to 15989 cubic feet per minute. In this lecture, we have estimated the grand total heat load, including that contributed by the fresh air. This worked out to 30.355 tons. We also worked out the dehumidified CFM through the coil to be 15989 CFM. In this lecture, we have shown how the various heat loads can be put together to arrive at the sizing of the AC plant, namely tonnage and dehumidified CFM. This brings us to the end of chapter 1, namely basics of heat load. Thanks for watching.